instead of trying to use Alice to generate fixtures and holding objects.
I mean,
that's the one thing I like about using Eloquent. Framework has built-in factory logic, so you can just define your factory of faker stuff, and then it can generate the models for you.
that would be too easy though.
I know. I'm asking for too much.
Wouldn't it be wonderful if every company that used Laravel took, for every full-time dev, took like 1 hour a week paid for that dev to give back to the projects?
That would be nice.
Or at the very least, if it was a, it would be better if this was a law, but if you're using open source software, you donate to the projects so that they can actually be properly supported.
Like literally everything other than Laravel needs that. Laravel itself doesn't particularly, but everything else is like either you give your dev time or you give your money. My deal has been the dev time side of things. My excuse being, oh well, I kind of need this, and there's no freaking point in maintaining it forward, so I'm going to build this out and then PR it. See also why you can use the Laravel container on its own now. Rather than pulling in a little freaking support.
I'm glad he actually accepted that PR. I was part of me that was concerned he was going to be a pain in the ass about it.
What was the PR?
It was duplicating some code from eliminating support so that you can pull in the Laravel IOC container with only PSR 11 as a dependency, and everything else it's completely self-contained rather than pulling in Illuminate support for it. So Illuminate container is actually not half bad to pull into an existing project and use as a container. I mean, the reflection-based stuff is not cached, so it's not the fastest thing in the world, but if you need functionality and you don't care about the penalty that reflection does, or you just define everything that is on the hot path of closure, then it's fine. And like the example that I did in Bulgaria when I presented was using Laravel container with Slim.
Oh.
And I would not have, it only makes sense to use with Slim if the container is not, due to Illuminate support, 50 times larger than the framework. Other folks were splitting hairs and hand-wringing about, oh, well, you're duplicating functionality. It's like, yes, I know. I've got tests for it. It's 2 functions. It's not the freaking end of the world. So hand-wringing continued, and then Taylor was like, I'm merging this.
Deal with it.
I'm glad that you merged that, because that seems like the prime kind of thing for him to just go, no thanks to merge.
It helps that we've seen each other in person and talked. He bought me Ethiopian food a few years back at Lone Star PhD.
Nice.
So it's all good.
I really would like to make a pull request to make it so that collections only pull in the contracts and nothing else. Or if, I mean, kind of has to pull in the contracts, but.
Yeah, it has to pull in the contracts, and I think
I suppose in one other thing, I don't remember what.
probably Illuminate support, because freaking everything pulls.
Well, it's in Illuminate support.
Okay. Oh, so you want a subtree split for collections?
Yeah.
Hmm?
Because the Titan collections package, which is basically just separating out collections from Eloquent or from Laravel, is actually pretty popular.
Yeah. Yeah, and it would be nice if you drove enough of a wedge between collections and the rest of the application that that you could subtree split that out as well. Question is how much effort it took Titan to do that. Is Collect still maintained?
I think it's still on version 6, so it is technically still maintained. Yeah. But it's gonna lag behind.
Yeah. You look at the code, see if you can do it, and if you can get a clean break to where you can do a subtree split similar to.
I think the problem though is that it relies heavily on the ARR helper, the R helper. So you have to make it so that it just no longer has a reliance on that.
Either you do that, or you pull the array helper out of Illuminate support, re-include it as a dependency of Illuminate support, pull it into its own namespace, and then only require that inside the collections system, which is a reasonable thing to do if you're willing to put forth the effort to do it. It's not
Both of
easy
those
break.
though would be backwards compatibility breaking.
No, because what you do is if you pull, if you say, right now I have A plus B as one package, I pull out A and make it a dependency of B, then anything calling A or B, if it depends on B, then it's still going to get A.
I just mean that if you have to change the namespace, then it's gonna backwards compatibility breaking.
What you would do there is have a shim class, just class Illuminate support R extends Illuminate arrays. So it'd be like 4 lines of code, and so you don't have to break BC for it.
That's fair. Yeah. I mean, you could technically make like a collections-esque package that just has everything for managing arrays and collections all in one thing.
Yeah, but then at that point you're duplicating code.
Yeah. Oh no, I meant so like you separate the array helper class and the collections class into a separate package together.
Oh, right, because Illuminate support includes collections.
It also includes like the string helpers and a bunch of other things.
But point being, there's no subtree split for collections right now. So if you split things out as the Illuminate collections plus array package stuff, then that's still fine because you can just require that right back into Illuminate support.
Yeah.
That's fair. My guess though is even though it's one extra package, it's probably slightly clearer and people would look at you less weirdly if they were 2 separate packages, where it's like collections depends on array, support depends on collections and array. Which has the added benefit of being able to pull just the array stuff in if you really want it. Which some of those functions would be nice to have in core.
For sure. So I'd like to, I think we were talking about this previously,
The extension that you don't want to install?
No, okay, I do want to install it. I do want to install it, believe me.
You don't want to go through the trouble that is required to install it if you don't want to install it. Gross over simplifications are the most fun things in the world.
Trying to get my boss to allow for the installation of it, though, that would be an effort in futility. Maybe if I'm working in a space that would be a little bit more flexible for that kind of stuff, then yeah, I would definitely look. But I mean, trying to get them to use Laravel was a pain in the butt, and I eventually just had to like force my way in with Laravel, and then was like, here's the benefits. You see, look, and
look at all this code I don't have to write.
Yeah. They were
look at all these potential devs that could replace me.
They were of the opinion that everything they should be writing themselves.
Oh, so y'all are going to write everything in assembly language because you want to write everything yourself. So you can't trust Clang or GCC because you want to write everything yourself.
Pretty much. All right, I'm going to go ahead and get the show started. I think we'll give people ample amount of time to show up if they're going to. And maybe we'll still have some late stragglers. So, welcome to Laravel Austin. It's our third one of the year. We're going strong. That's the right point. I want to thank our sponsors, Review Push, for providing an exuberant amount of pizza tonight. There's a ton of it, so there will probably be a lot to bring home if you'd like to bring some home. Unfortunately, Eric couldn't make it tonight, the other Eric from Review Push, so we can't thank him in person, but thanks, Eric. Some of the housekeeping stuff real quick before we get into it. I see I'm now focused. There we go. So we've got the Austin PHP Meetup next Thursday, March 12th. Do you have an idea of what the topic may be?
I'm not sure. There is a topic, as I recall. I just don't recall what it is.
So there is. Either way, I definitely recommend checking out the topic and checking out the meetup. They're basically our sister meetup, and they have a lot of great stuff, so I recommend it. As for our next Laravel Austin meetup, that'll be next month, April 2nd, just one day off of April Fool's Day. So close. One day we'll line up, and I already have something planned for that. But next month, there's a strong chance now that Laravel 7 has been released with all kinds of newfangled bells and whistles, why they'll be kind of overviewing some of the new things that Laravel 7 brings, or we'll just dive specifically into Laravel Airlock and take a look at that new package that simplifies authentication with SPA style applications.
You could wait until I'm back for the Laravel 7 one because I want to see the new stuff.
Okay.
I don't care about Airlock. Hashtag T-Mobile.
For reference, by the way, the PHP meetup next week is data science with PHP machine learning.
Oh, sweet.
Who's doing it?
Hosted by
Derek.
It says Derek and Logan.
Let's give it a talk. Okay.
Derek.
Nice. Cool. So if you're interested in data science and machine learning with PHP, highly recommend checking it out. Otherwise, as for conferences that I'm aware of that are coming up soon, we've got Midwest PHP, April 2nd through April 4th. So if you're going to be at Midwest PHP, then you won't be here. Sounds like Ian will not be here. I believe he's presenting at Midwest. And then I'm sure I'm missing a few others, but PHP Tech is May 18th through the 21st.
You aren't actually missing any PHP conferences between those two.
Sweet. So for once, I actually got all the conferences lined up that I know that are coming up soon. I don't have a bullet point for it yet because I try to keep the dates pretty close to each other. But if you missed the announcement, Longhorn PHP is still happening. This year it'll be October 15th through the 17th.
Yep.
We've moved locations, so it's a little bit closer to downtown, a little bit more central area of Austin, so you can actually go forth and check out all the cool things downtown and all that.
Rather than being stuck in the domain.
Yep, and also it's hosted at a hotel, so you don't have to go to be at a hotel that's a few miles away from the location. You can basically be at the location, which makes it a lot easier, especially if you went out and had time with friends. You don't have to go as far next morning when you're totally not hungover and struggling.
Sounds like stomach bug, by the way.
Oh, I'm not
Thank
making
you
any
very
digs at you. I'm more just knowing my past
It had
experience.
nothing to do with the 3 beers I drank.
That day that I drove you home in the...
Yes,
something like
yes,
that.
yes.
Yeah, you were
Thank you for
definitely
doing that.
bugged.
It was more of a, I know I've been to a few conferences myself, and I definitely enjoyed the fact that the hotel was also where the conference was. But tickets are
And it's
now
a
on
mile
sale.
from my house.
Yes. Blind Bird tickets are currently on sale, so you won't be able to know what the schedule or speakers really anything looks like at the moment, but it's the cheapest ticket price you can get. $100 for tutorial only, $200 for conference only, and surprise, surprise, $300 for the whole package. So if you are interested, we'd love to have you there. I definitely recommend grabbing your tickets now. It'll be the cheapest price. Maybe we'll probably do some Meetup type discounts and stuff in the future as we get closer towards the conference, but
that 200 is the lowest it's going to go.
yeah, that 200 is the lowest it'll be. So $200, conference in town, 2 days of awesome learning opportunities and hanging out with people in the community from all over, at least the country, possibly the world. We'll see how this whole COVID-19 thing plays out. Yeah, we'd love to have you. But that's all I've got for back of house stuff and plugging the conference we all organized. So I'm now going to hand it over to tonight's speaker, Ian Lippman. Take it away, Ian.
Yeah, maybe we'll actually get more speakers because the flight's going to be cheap due to this COVID-19 thing.
Right.
Oh, $500 round-trip flights from your, yes, we'll like
Yeah,
6
absolutely.
speakers. All right, so we're talking about load testing today, and if you want to, you can follow along at that URL. I didn't bother making that force you to follow along because then I would have to change it later to not force you to follow along, but that's where the slides are. Code is linked at the end of this presentation, and yeah. So we're going to talk about load testing your app. The only reason Hunter let me show up with this at a Laravel meetup is the system under test is actually a Laravel app, and the stuff does apply and the bottlenecks do apply. So when you're building out an application, you want to like make sure that users actually use it and aren't yelling at you and that sort of thing. Particularly on a web application, you have kind of 3 pieces there in addition to does the thing actually do what somebody wants it to do. First off, speed. So that's measuring latency and the number of hundreds of milliseconds or seconds it takes to load the page. Scalability is the number of simultaneous requests that you can field, and simultaneous requests are not simultaneous users. We'll get into that later. But scalability is the number of simultaneous requests that your server can handle before melting down into a puddle of gray goo. And stability, because neither one of those 2 things matter if you're very quickly and very scalably serving 503s or 500s or 504s or 502s or 404s. I hear that Nginx serves 404s really quickly. You don't want that on the dashboard of your application though. So these are the 3 metrics that we're going to be measuring when you actually try to load test an application. So with that in mind, what we're going to cover today are first we'll define some terms of what exactly is the difference between a smoke test, soak test, spike test, load test, stress test, and what those terms actually mean, and what sorts of bottlenecks that you'll end up showing by each type of test. And then we'll go into when you should even bother with building out load testing, because as we'll see going further into the presentation, in order to do it right, you're going to have to spend a fair amount of effort understanding how people use your application and then building out the test infrastructure as well. We'll go into actually building out some of that infrastructure using a tool called K6, made by, well, now they're K6. As of, about a week and a half ago, they changed the name from Load Impact, which is, they've been doing load testing related stuff for a while. And then we'll actually look at load test script. We'll look at a lot of things that you want to keep in mind when building out that load test in terms of things like, hey, nobody's going to be clicking through your website link after link after link almost instantaneously unless they're scraping your site. You're dealing with real users. They have varying behavior, and we'll look at how to simulate that varying behavior. We'll also look at what some of the bottlenecks you might see in a PHP focused application. And we actually will be demoing some of this load testing stuff with case 6 toward the end of this presentation. So, with all that said, I'm not going to cover a fair amount of stuff here because, for one, case 6 is the load testing software that I have actually used some. Eric is the same thing that I used on the project where worked with you, which was honestly the inspiration for this entire talk. So in previous versions of the presentation, I threw Siege up on screen and did some tests there. While it's a fine tool, it doesn't necessarily get into the level of detail that we'll be looking at on a more think of what I'm going to show you is like unit tests, except you're doing a whole bunch of them at the same time, or end-to-end or integration tests, depending on how you want to slice it. Also, there's a concept of clustered load testing where you have multiple endpoints supplying load to an application. And in a lot of cases, in order to bring enough load to bear that you're either simulating enough users to satisfy your curiosity or bringing your entire system down, that usually takes a single system for small and medium-sized systems under test. You may need to vertically scale that system, but the systems under test that I'm using in the load test software itself, I'm just running it on like a gig machine, and the particular one we'll be looking at is generally rammed down. So that said, if you're testing a larger system, you may need multiple endpoints all hitting your system under a test at the same time. And there are certain load test systems that can do that. K6, as deployed the way I'm going to show it, is not one of them. We're also not going to look at testing from the perspective of far-end users, where you have additional latency and potentially lower connectivity between the simulated users and the system under test. That may change the results of your test a bit if connections are held open for longer than expected and are thus using resources that may not have been used otherwise. But you can approximate things fairly well depending on the use case by testing from within a data center, and that removes, if your idea is to test the application itself and the services behind it, then it doesn't make sense necessarily to test, say, Amazon Web Services connection out to the wide world. So you have to be clear on what you're testing. We're not going to test foreign users in this case. We're also likewise not going to test performance of your HTML, CSS, JavaScript after it gets delivered down to the end user. Realistically, as load scales up, your end client doesn't necessarily care about how much your server is loaded. It just cares about whether things return quickly enough and don't 500. So you can throw, say, web page test or something like that at your system, and it's going to perform about the same with a minimal amount of load versus higher load, as long as latency and such aren't too much affected. We're also not going to look at deep application profiling, saying what Blackfire does on the extreme end of things, or even what an application performance monitoring system like New Relic is going to do. That is a different, that is a whole different discussion, and you don't want to use Blackfire during load test anyway, because the instrumentation that Blackfire adds to your application slows things way, way, way down. You do want to use your APM while you're load testing for reasons I'll go into later. And finally, we're not going to talk through how to, quote, load test, say, a large amount of input or some long-running process that is only really one user wide, but you're just dealing with a bunch of data. You can use your standard integration or end-to-end test for that. You don't need a load test for that. So, with all of the things I'm not going to cover out of the way, again, we are going to be testing with K6. It's written in Go. You actually script it in JavaScript. One weird thing about the JavaScript that you write for K6 is that it is synchronous in locking each virtual user that you're simulating hitting your site gets its own little Goja runtime, which again, you can use JavaScript there. It is not Node, it is not V8, but you can, via Browserify, pull in JavaScript modules that you would find on NPM. In fact, that's for the example that I have, I pulled in one of them so that we can get mathematical distributions for modeling how much time it takes for somebody to bounce between pages. So it is JavaScript. You program it a little bit differently. We'll see exactly what that looks like later in this presentation. If you want to, there is an add-in that will let you pull in HAR files, which you can generate from Chrome in order to simulate, okay, well, this is the actual traffic that I generate when accessing a page. The caveat to that is you're going to want to take that as inspiration and then parameterize those variables out of there so that you're not assuming that people will hit the site the exact same way that you do every single time. So, a couple of definitions here. Smoke test, load versus stress, and soak versus spy test. Jump right in here. A smoke test is not actually a load test, although you could use your load test script if you turn things on to run things thoroughly to do a smoke test. And the idea of a smoke test is it's just an integration test. And if your application doesn't work at one concurrent user, then you've got no hope at 10 or 100 or 1,000. So the first thing you want to do before spending all of the time and effort and money, because since you're simulating a fair amount of traffic to your site, that's going to cost you potentially just as much as if real users interacted with the site. You want to make sure that the site works in the first place, so you don't do 1,000 simultaneous users and get a whole bunch of 500s and then you wasted your time with a test. So you can either do that by, say, a standard integration test suite, something like Dusk, or alternately, you can take your load testing software and say, run one iteration or a few iterations back to back to make sure you hit various code paths if you have code paths in your load test, which in the example that we're going to see, we do. But run through the load test at one simultaneous user and make sure that that actually works. Once you do that, you have kind of four choices here. You have one dimension of anticipated, of how much load that you're generating versus anticipated traffic. If you're building out your test to throw as many users as you would see at peak or fewer, that's actually a load test. The more generic term for this sort of thing is a performance test. A load test is a subset of that. So in the case of a load test, you're just trying to guess at how much traffic you'll see at peak, and then when you run that test, your expectation is that your system is going to perform in accordance with your benchmarks on speed, scalability, and stability. Your system should not fall over when you're running a load test. If your system falls over when running a load test, that's called a stress test. The stress test is either increasing the amount of traffic to the site beyond peak or decreasing the amount of resources available to that application. So one way that you could do a stress test is pretend for a moment that US East 1 is being US East 1 and auto-scaling isn't. So at that point, all of a sudden you have your peak level of traffic, which you would normally have 4 or 5 web tier servers serving, and you actually only have 2 because when you told Amazon to scale up your services, they kind of ignored you because they were having an outage again. You wouldn't know that from the status page, everything's all green, but your servers aren't showing up. So artificially constraining resources or just throwing a whole bunch more load at it than you actually expect. For example, if you're Robinhood, Paul isn't here, so everybody make fun of Paul for saying that I should include this example in the presentation and then he doesn't show up. But if you're a certain free stock brokerage by the name of Robinhood, and apparently they had not load tested, or they would probably have argued, oh, it's a stress test because there's no way that the Dow is going to seesaw by 1,000 points day after day after day. Well, it did. So that's the sort of thing where maybe you want to increase your load up beyond what you expect your peak load is so that you can figure out where your system actually bottlenecks, for example, DNS, and actually fix those issues. So there you have the difference between a load and the stress test. On a different dimension, you have the actual length of the test being performed. On the one hand, you have a soak test, which is a long, drawn-out test, which also means it's kind of expensive in terms of compute resources used. But this sort of thing will allow you to figure out if your infrastructure is set up to do nothing particularly useful with logs, not rotate them and just let the disk fill up, and then the disk fills up, and then warning sirens are blazing. But fortunately, you're doing this in a test environment, so you realize that that is an issue, and then you fix it so that that same logs filling up scenario doesn't happen at 2 a.m. on production. So likewise, you'll see things like memory leaks, and on the positive side, you may actually have slightly better performance as time goes on a soak test because of if you turn on the JIT that'll be available in PHP 8, maybe the runtime figures out what the hotcode paths are and compiles those down, and you get a bit better performance in that case. Or if you're using UTXVM now, which you probably aren't because they've decided that they're not going to really care about PHP anymore. Those are the sorts of things where a long drawn out test actually may have better performance sustained than the quick test set up. Now, the opposite of that on kind of this quadrant of how you build your tests is a spike test, where you're throwing a whole bunch of load at your system all at once. And you might think, well, do users actually use my system like that ever? And the answer is, if you're Woot.com, where you have a new product every midnight, then yes. If you are advertising something on TV on the Super Bowl and say, don't delay, go to this website today, then a whole lot of people are probably going to go to the website and you'll get this flood of traffic. Or maybe your site gets featured on Reddit or Hacker News and you get the Reddit hug of death. Those are all sorts of scenarios where a spike test, where you're throwing a whole bunch of load very quickly at a site, scaling users up quite quickly, may actually reflect a use case that you see in the real world depending on what type of site you're running. So as an example of this, Troy Hunt at Have I Been Pwned got a huge spike of traffic. He was like, are these bots or is this real? And it turned out, yeah, it was real traffic. He had been featured on an Italian TV show, an Italian news show, about the benefits of not having your passwords breached and actually keeping that sort of thing safe. And they mentioned Have I Been Pwned, and then a whole bunch of people went there. So if you wanted to simulate a scenario like this, what you would be building is a spike test. So, with all of that said, we're done with definitions, at least that level of definitions. Let's talk about when we should actually bother with building load tests out. And really it comes down to two things. Either your application is going to perform differently and you want to see how that difference in performance due to difference in application structure or what have you pans out, or if you expect your end user traffic to happen quite differently. And these two things can interact. Going on about 10 years ago, I believe now, Google introduced something called Instant, where you could start typing a search query and they would start pulling up results for you once you had typed in a couple of characters. And that was a change in user behavior, but that big change in user behavior was predicated by a change in infrastructure on their side, where they were throwing themselves like 6 or 7 times as much traffic as they were previously. And maybe they could make that a bit more efficient, because if everybody is starting out typing, say 2 or 3 letters, okay, 2 letters, that's maybe 26 times 26. Okay, you're looking at only about 700 different search result types for the entirety of search queries at 2 characters, so you can probably cache those and not have a horrible amount of latency there. So you can see this interplay between the amount of traffic that is being thrown at the system and the actual infrastructure of the system itself. But the only times that you would want to build out a load test is if you expect, hey, we're going to get a bunch more traffic because we're doing this promotion, or we're broadcasting that this new feature is online, and we want to make sure that the system doesn't fall over as a result. Or if the user behavior you expect to be about the same, but you've done this big refactor, you've added or removed indexes, and you want to make sure that the changes that you made to that infrastructure have not created a performance issue for you. So those are the 2 times you want to do. So one key thing on load testing is it's not worth its salt unless it actually replicates a scenario that we would see in the real world. You want, because you're going to be spending a fair amount of time and effort building this thing out, you want it to replicate a scenario that you would see, so that you're actually preventing potential problems from happening in a production environment. Just like you would expect a unit or integration test suite to do for any single user's actions. So, throughout this presentation, with a focus of having an accurate test, one of the pieces there is testing flows rather than single endpoints. Unless your application consists of one endpoint, people will likely hit a series of endpoints or make a series of web requests through your application with different parameters, and one user's parameters are likely going to be different than the next user's. Their pass through the systems may vary, and you want to actually reflect that in your application. Now, if depending on the question that you're trying to answer, the question may be, have I introduced performance regression in this particular page? And maybe in that case, you want to just proceed to that page and see what happens. But if you're trying to holistically see whether your application is going to stand the test of actual production usage, then you want to test users' flows through that application in proportions that reflect how people are actually going to use the system. And when you're building that list of flows out to decide what to test, you not only want to grab the highly used endpoints or the endpoints that your stakeholders tell you are important, but also endpoints that may take a little bit more computational intensity. So if every so often an admin pulls some sort of big report that throws a bunch of queries at the system that may or may not be indexed, you want to include that in your load testing scenario in whatever proportion you see that in real life, because if that particular endpoint is taking 100 times more effort to load than, say, your standard dashboard endpoint, and that's happening, 0.5% of the time, then congratulations, that is about a third of your load right there, and not including that endpoint would be understating the amount of traffic that you actually have on the system. So think of flows rather than single endpoints, and then make sure that those flows encompass all the behaviors that you care about in the system, plus the behaviors that, if you forget about them, might take your system down because they're computationally expensive. So one thing to note here is, if you're dealing with, even on the side of APIs that you're making available to kind of business to business, this applies, but absolutely in the case of web applications that you're working with end users. A concurrent user doesn't translate directly to a concurrent request. One caveat to that is, if you're dealing with WebSockets, we're in a PHP meetup, we're not usually dealing with WebSockets. So I'm hosting these slides on slides.com, and I'm a concurrent user on slides.com. However, most of the time, I'm not a concurrent request on slides.com. I'm sitting here, or standing here, presenting, and putting a negligible amount of strain on their systems until I change slides, in which case I make a request. They respond with the slide content back, and I go along my merry way. And so that is one side of concurrent users are not concurrent requests. You're likely going to have a lot fewer concurrent requests than concurrent users. And so maybe, depending on the size of your application, 30 concurrent requests or 100 requests per second is actually enough to serve 1,000 or 2,000 or 5,000 concurrent users. Now, the flip side of that is that if you're dealing with an API where you have, say, a single page app where you're calling a bunch of HTTP endpoints to build out, say, a dashboard for you because you're trying to be as RESTful as possible, that sort of thing will give you a whole bunch of requests simultaneously from a single user. So in that case, you might have a single concurrent user firing off 5 or 6 concurrent HTTP requests. Now that we have HTTP 2, now that there's not that artificial limit of, say, 2 or 4 requests per domain in flight at the time, you may have a bunch of concurrent requests, and your web traffic may be quite bursty. If you don't take that into account in your actual load test, where you're hitting multiple different endpoints at the same time for a single user, then you may be understating your traffic. Finally, actually 2 more things here. First off, you've got the amount of time. So the amount of time that I'm spending sitting here on this slide without actually moving forward or backward is, you would model that, or you would call that think time, where you're sitting on a page deciding what to do next, or doing whatever you need to do on that page, but not actually involving network traffic or anything that puts load on the server. We'll look at how to model think time in a moment. On the other side of things, you have caching as well. If your client side is caching, or CDN is caching, or you're actually having correct caching headers from your server side, then a number of common requests that would normally go all the way to your backend and have a fair amount of compute required there can actually get served well in front of that. And as your load increases, then, or as the number of concurrent users or concurrent web requests increase, that doesn't necessarily cause a linear increase in the amount of computational power that those requests require. So there are a bunch of ways to get that idea of think time wrong. First off, there's always going to be think time, even if you're dealing with an API that gets operated on directly by some external system on a cron job. There's still some level of processing time in that cron job, and there is going to be some variability there. Likewise, if you are dealing with an end user facing application, most of your end users are not going to be web scrapers. So they're going to go to a page, call the resources that are needed to load that page, and then sit there for a while. And you don't want to model that by saying people are just going to push all the way through the application, not stopping to read what's on the page. They're just going to click through that. That's not actually a way people use your site. Likewise, people are not going to go to a page, sit there for exactly 10 seconds, and then move on to the next one. Nor are they equally as likely to spend 5 seconds on the page as 6, as 7, as 8, as 9, as 10. That would be a uniform distribution. In reality, these sorts of think times are going to have kind of a bell curve looking thing where you have an average and a standard deviation. You'll use a normal distribution for that, and fortunately there are packages out there that calculate those distributions for you, so you don't have to reinvent the wheel. Now, you might think, okay, well, normal distribution, that's cool, I'll just add the package in and we're good. Well, you may have different types of users. You may have novice users who are hitting the website for the first time and need a little bit to look around and understand what's going on before deciding what to do next, and then clicking the link. You may have mid-range users who still may need to be oriented on the less used parts of the app, but generally know what they're doing and proceed relatively quickly to the next thing. Or you might have expert users who have keyboard macros set up to click through the website as fast as they possibly can, approaching the speed of some random web scraper. Those will each have different distributions, and you'll likely want to layer those on when determining how long somebody sits on a page before going to the next one. And also those users may have different use cases, so they may visit different pages as well. In the example that I'm giving, we aren't going to go that far. We'll just use the standard normal distribution one at a time, but it's something to keep in mind for accurately modeling how much time somebody spent on a page. So a couple more oversimplifications that you don't want to fall into, because if you fall into these, then you have an inaccurate test and you've wasted your time. First off, who here is working on an application with no data in the database? Yeah, I thought so. You want to have your system under test have data in the database that not only is roughly the same quantity as when real users actually hit the system, but also what I would term the same shape, which gets tricky with personally identifiable information, yes. However, getting something via, say, Faker or something like that that approximates, say, the distribution of email addresses or usernames or first and last names or phone numbers or anything like that allows you to replicate situations where a database may choose to use or not to use an index based on the information that you feed into it. So merely taking your existing data set and then filling it all up with noise instead of actual values will cause differences in behavior in your database indexes and potentially other portions of the system in terms of cacheability and the like that will affect how well your load test approximates real world. Another pitfall is not parameterizing your requests. So if you don't parameterize input such that it varies from user to user or from request to request, then you end up creating a gigantic hotspot in your application that at worst gets almost immediately cached and and as a result, makes you think that your application is going to handle load really awesomely, and then it doesn't. Or on the other side of things, you end up with a hotspot in the database where normally the database would be absolutely fine. Requests would be kind of spread across the entirety of the table, but in your test, they're all hitting the same set of rows and causing performance to actually go down. So yes, it takes a bit more effort, but in, for example, the script that I'm showing later, I'm actually going through the entire user list and saying, well, you're going to log in, 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 and each one of those is going to have a slightly different path through your system in order to accurately represent the load profile of what I expect that the system would be used in production. Also, people will leave your site after performing 0 or 1 or 2 or 3 or 15 actions. And that drop-off will give you a little bit of extra capacity to serve load, and does actually happen in the real world. Now, you're going to want to inform these abandonment percentages at each step with real-world data if you possibly can, but keep in mind that that does happen, and I've actually built that into the load test script that we'll be seeing momentarily. And finally, along with abandonment, you may have input errors where somebody enters their username or password incorrectly when attempting to log in, and that validation may be faster or slower than the happy path on your application. Particularly if you're having something where you're, say, causing an email or an SMS to be sent, and that causes an API call that takes a couple hundred milliseconds somewhere else. If somebody fails to validate on input, that buys you a little bit more time, decreases the load on your system at any given point in time, versus taking that request and actually going all the way through with it, if your validation is happening early in your request lifecycle. So you want to likewise simulate that in your load test, and we'll see that in the load test script that we'll look at. So on top of all of those things to not forget, you also want to vary the profile of your load between different tests. In certain cases, you may want to bias your test toward heavier traffic. Maybe your cache goes away, or there's some caching related bug such that things that you thought would be cached actually hit the web tier. Or maybe your cache runs out of room or something to that effect. That would be kind of a heavier load profile. On the other side, you may have a higher incidence of validation errors, or the sorts of things that would spread your web traffic over a longer period of time. That's a lighter load scenario. You don't want to just test with one set of parameters and say, okay, we're done here. So here's an example. Again, this is trivial, a little bit contrived, but the idea of this is we have a super basic fitness tracking app like a Strava or something like that, where you have really two resources in addition to a set of users using the system. One is activities, which have a distance and a time, and one is challenges, which is I challenge whoever wants to join the challenge to perform X number of activity, or X amount of distance or X amount of activity time between X and Y dates. Oh, and yeah, the activities have a time that's associated with them on when the activity started. So, and as with any sort of competitive thing like this, you have a leaderboard. Spoiler alert, leaderboards are computationally intensive, and that combined with a relatively naive implementation of Laravel meant that I had something that was slow enough under test that I could demonstrate, okay, here's a load test, here's it being slow. Now if I turn around and optimize it, then here's it being fast. So it was a nice, quick way to build a system under test. This is fully Dockerized. It is running Laravel 6. If you want the Docker compose file to build this out. I don't think I have the exact one checked in, but ask me, I'll get it to you. Anyway, in this case, the first step of this process is attempting to log in. In certain cases, we are explicitly going to provide incorrect credentials and then decide whether to provide correct credentials because the person remembered their password or have the person bail out entirely. If they successfully log in, let's say this is a single page app and it's calling it to a bunch of endpoints. Those endpoints are all going to be hit simultaneously for that user. It's going to pull down their profile and their activities and challenge leaderboards. From there, the user is going to sit there and look at the homepage for a bit and then decide what to do next. They might record an activity and then maybe record another activity. Or they might create a challenge some percentage of the time. Or they might abandon after looking at that homepage. In each case, there's going to be a think time that we're simulating as a normal distribution between the time that they view one page and view the next one. And there's going to be a probability of moving on to a given step. On top of that, for cases where there is user input, we are varying those input parameters so that not every activity is exactly 15 minutes and 3 miles or something to that effect. So let's actually see what a script to build that test out looks like. This script is linked here if you want to look at it. I'm going to kind of go almost line by line through and read most of it in the subsequent slides. So first off, we're going to import a few things. Notice toward the bottom there that I'm pulling something from a GitHub gist because rawgit is unfortunately no more. That gist in it has a browserified NPM module for mathematical distributions. We're just using the normal distribution from it. So you can use node modules in here, however, this is not Node.js. You do have to have an additional transform step between point A and point B. There are a number of things that are built into this K6 runtime, and we're importing some of those there. We'll see the HTTP library and your trends and check, fail, and sleep methods and that sort of thing later. And again, sleep is not like JavaScript set timeout, it is actually synchronous. So you end up writing these tests a lot more like PHP than traditional JavaScript. So once you do that, we're actually pulling in various data to feed into the test itself rather than hard coding it. So I've just got a basic configuration file format here. The app is authenticated by OAuth, so I need a client ID and secret to do that. We're using password grant, so we have what we need there. And then I had generated a bunch of users and activities and challenges via Faker to seed the database. Nothing terribly special about that there. And then I pulled the list of users back out of the database via MySQL dump, or I didn't use MySQL dump, I used MySQL dash capital B to give the tab separated value as one row, so it's just, or sorry, one column, so it's just a big old list of emails. So we're pulling that in here, and a limitation of K6, which is a completely reasonable limitation, is that when you're building out this setup phase of a load test, the only time that you can read from your file system is in that setup phase, because when you're actually generating your load, you don't want to cause more CPU usage on your load test machine than you can absolutely afford. And if you're sitting there trying to read from a file and do I/O that way, then that's going to slow things way down. So K6 says if you want to deal with the file system, the only place that you're doing that is in this initialization setup, which manifests itself as this stuff happens at the top level of your JS file or inside functions that you call from the top level of your JS file, rather than in a function that you export, which we'll see in a moment.
Excuse me, I was just walking by. Which language is this?
PHP.
I did not register. Would it be all right if I sat in?
Go ahead.
Sure, go
Thank
for it.
you.
So I said this is PHP. This isn't PHP. This is JavaScript, but
Yes,
it,
that's right.
yeah.
Passed.
So the next thing that I do here is I set up a bunch of constants for probabilities and distributions and that sort of thing to say, to basically replicate this model right here. It's like, okay, it's a 5% chance that we move on from step A to step B, 95% chance that we do something else. As we go further down here, we get into the actual variance and input on creating activities or challenges, which again is important because that's going to feed into how much calculation the leaderboard side of things takes. And we're trying to do a couple of tricks here, like specifying activity speed and multiplying that by the amount of time that something takes, rather than just having activity time and distance independent of each other, because if you have time and distance independent of each other, then you end up with data that's not really real. You have somebody that the random math function decided that they were going to do 15 miles and were going to take 2 minutes to do it. So we've got our probabilities here, we've got our activity minimums, maximums, that sort of thing. And then we go into actually building out some distributions for our think times that we mentioned earlier. So these are the times between the steps, and while we could be a bit more advanced on this and actually overlay distributions, we're just going to use a single normal distribution for each of these of X number of seconds between the time that you load page A and the time that you, after deciding what to do, load the next thing. Then we set up what K6 calls trends. It's buckets that we can throw data values into, and then K6 will spit those back out as average, which you don't really care about, median, so 50th percentile, 90th, 95th, and 99th percentiles on its data output, or you can, depending on where you are pushing data from or into on K6, you can access these metrics that way, and it will aggregate them for you. And thing to note here, K6 allows you to push those metrics into various kind of sinks. In addition to showing them at the command line interface, you can push them to InfluxDB and then throw Grafana on top of that, which we'll see in a bit. Or you can push them to Datadog, or you can push them to K6's own cloud UI that you have to pay for. So now that we've gone through setting up probabilities, trends, pulling in our data, we can actually do this export default function, which this is the thing that runs every time a virtual user runs an iteration, so one run of this of the load test across your application. You may tell K6, hey, give me X number of concurrent users, ramp them up over a certain period, and have either each of these virtual users run through the simulation 100 times, or run as many iterations of this simulation as you can over the course of 10 seconds, and then either stop or ramp up to another user count or that sort of thing. You have a lot of, you have the ability to even programmatically define how your load test is scaled up or down, but in the test itself, you're going to, each iteration is going to execute this function. And you do have a couple of environment variables, so to speak, that will tell you, okay, you're on this iteration ID counting up from 1, or this virtual user ID counting up from 1. But in the case that we're looking at here, I actually don't use those and just kind of treat everything independently. So first off, we decide what to, whether we're going to provide a correct login or not on this initial step. And as I mentioned earlier, we want to, as part of these load tests, simulate input failures as well as successes, because not every interaction between the user and your application is on the happy path. So we do that here, and we grab a random email out of that list of emails that we imported earlier. And that random int function there is something that that I built out. If you look in the actual code for the script, that's not something that comes with case 6, but it's a one-liner that uses math.name on the hood, so it doesn't really matter. So once we've decided what email we're going to throw into this login form and whether we're going to provide the correct password or not, we actually make a call. Notice that there's no async or await here. Again, this is synchronous JavaScript, which is really weird, but since each virtual user has its own little Go runtime that's executing JavaScript, it's fine. You can do concurrent requests. We'll see how to do that in a moment. So we do this standard OAuth password grant login here and get a response back after we decide, are we going to provide the correct password or not. If we don't want to provide the correct password, then we're going to expect something different. So first off, we want to see if we gave them a correct, we gave the application the wrong password, did we get the expected error back? And that's the first place that we see this check function that K6 provides us. And it's just an assertion where you can decide what to name that assertion. Then you have a function that operates on the response and returns Boolean. In this case, we're seeing this should 401, we should have had a failed login. And that check itself will return a Boolean, which we can then, in addition to being instrumented on the command line interface, etc., it will return a Boolean, so we can fail the entire test and say, look, if this failed, then bail out of the entire thing because something is wrong here. Alternately, if you want to, you can continue the test by just calling check and moving on. But I think in a fair number of cases, you're going to want to fail out of that entire iteration of the test if you see something unexpected. So at this point, we decide, okay, well, we've gotten the response back. If we've gotten this far, we've got the response back that we expected. It's a 401. Now, do we decide to enter the correct password next time, or do we want to decide to bail out entirely? And if we decide to bail out entirely, the iteration ends and the runtime goes to the next one. So this does mean that an incorrect login will actually, if you have a whole bunch of incorrect logins, then this particular load test system may increase the number of iterations that run depending on what parameters you're feeding in, but it's probably fine for our purposes. So if we decide I'm going to try and submit this login process again, then we go ahead and make the same request again, and see if and check for the response being a 200 this time, and then go forward from there. So if we say, okay, that we expect the login to succeed, then we check for 200 here, and we look at we look to see whether the access token, we got something back, and there's this nice little JSON helper that, unlike your standard, your newer response JSON helper on fetch, this one is synchronous, so you just do .json and then check a field. Check that, make sure that the response is there, or fail out of the entire test if you can't log in successfully. So once you've logged in, the idea there is there's no user interaction required for the next set of requests, so we immediately launch into it, which is grabbing those 3 endpoints that I mentioned earlier, and those happen simultaneously. Here I've extracted the common logic between those endpoints up into this let prims here, and then turned around and use this HTTP batch method within K6 to say, fire off these request objects simultaneously, and then the responses that you get back are actually indexed right back into that object. So in each of these cases, we see, hey, does that response body actually have what we expect in there? And if the response body does, then it works. If we have something unexpected, then it doesn't. And that level of, at this point, we're effectively integration testing our API interactions, but doing it at the scale of multiple simultaneous users, 10 or 50 or 100. So if we have an API that falls over at a certain point or starts giving incorrect data at scale, then we can actually catch it rather than just saying, well, we got a 200 back. We don't really care about the data. We don't care if it's consistent or not. So you do those 3 checks there, and then for the response time itself, each response has this timings object, and that timings object has, among other things, this duration field to it. So we can drill down into that and then throw it into the trend objects that we set up earlier to say, hey, K6, keep track of the amount of time that this particular endpoint took to return, because we're going to want to look at percentiles on it later. So after we load that initial dashboard, we want to decide what exactly do I do next. Do I abandon? Do I create a new activity? Do I create a new challenge? So that's what we're doing here, and the probability map I'm pretty sure works. You all should check me on that. Either we abandon, or we sit there for the amount of think time that we've decided, which this from dist method, I believe that's another one that I added that wraps that distributions on it and says, okay, for this distribution, give me back a number of seconds that I should actually wait here. So we wait for that amount using a another call that we're not having to await anything. It's just sitting there blocking. And let's say that we're creating a challenge. In this case, we're doing a whole bunch of setup because this is a relatively complex object, but in each case, we're trying to vary the input and vary it in a way that users would actually follow. So a user is not going to put in, I challenge you to, for the next 2.5 days, to have at least 16 minutes and 35 seconds of activity and at least 4.09 miles of distance. That's not how people are going to select numbers, particularly if we have validation client side disallowing them from that. So you'll note the names of some of the variables here. I'm actually trying to take that into account so that things are all in nice, neat lines. Now, on the activity creation side of things, I don't do that because you might have an activity that takes 17 minutes and 21 seconds or 17:22 or 17:23, and that matters a bit less. So create that challenge, look back to see whether that challenge was created, and also we want to call that challenge list endpoint and make sure that we don't have some weird eventual consistency bug or something like that where the challenge creation endpoint says, yes, that was created, but the challenge list endpoint has no idea what we're talking about. So we're trying to avoid false positives where the system says it behaved successfully, but didn't actually. So that is, there's additional code in that particular test JS file that does kind of the same thing for activities. I'm not going to go into that here because I've taken long enough, but you can look at it on GitHub and see what's there. So one thing to note here about K6 in particular is it follows a looping model of these virtual users. As soon as a virtual user finishes one iteration of the load test, it's going to go immediately into the other. That does mean that a slow server will actually slow down the amount of traffic that the load test situation is throwing at it. And you'll need to keep that in mind. Now you'll get information at the end of the test of how many iterations and how many virtual users and that sort of thing. But potentially a better way of handling things like this is an arrival rate based testing system where the load test system guarantees that for any given point in time, X amount of new traffic, X amount of concurrent users will hit the site at the same time and scale up such that 10 or 15 or 20 seconds or a minute in, the behavior there is based only on the configuration of your load test rather than what happened 10 or 15 seconds before in terms of the server responding slowly. K6 does not quite have arrival rate-based configuration yet. They have been working on it, but they've been working on it for a while. And unless something changed in the last day or two, they still are working on it. The highlighted links there are to the GitHub issue explaining what's going on, and as well as the in-progress fix. So when you run this load test, you're going to get a lot of metrics back. And you're going to want to ignore averages because averages kind of smudge your data and don't really let you understand what's going on with the hood. An average is going to gloss over the fact that for a certain percentage of your requests, they responded really quickly and thus distorted the average because they were all 404s. You're going to want to look at your percentages, your percentiles, whether that's median or 50th percentile, where half of your requests are above and half your requests below. That's not necessarily the same as your average. And as well as 90th, 95th, and 99th percentiles. You might say, well, what do I care about 1 in every 100 requests? Well, if you're dealing with a web page, say a single page app that makes 10 API calls, then out of those 10, one of those calls is going to be in the 99th percentile about 9.6% of the time. So if that page is not finished rendering in a really obvious way until all 10 of those requests come back, then you do actually care about the 99th percentile, particularly if that 99th percentile is correlated because that one slow request that happens 1 out of 100 times may actually slow up your page a lot more often than you would expect. So in that example I gave about 404s returning really quickly, or maybe you have a group of requests that take significantly longer because there was cache exhaustion and you had to go back to the database to do some calculation because it had aged out of Redis. That sort of thing will show up as outliers on your performance data if you're kind of plotting things. You'll be tempted to ignore those and say, well, it's just an outlier, it's just a few requests, let's ignore them. No, figure out why those requests are sitting out somewhere else. And until you have an explanation for that, don't ignore them. Figure out why those are happening and potentially remediate them so that your system is more predictable. Which reminds me, I should run the test. Get this started here. That. Let's say that. So it's going to initialize here, going to pull some stuff from the configuration files that I've got, and it's going to perform load test. Well, not really load test. This is more of a smoke test. I only did a single iteration. But in this case, everything, my login succeeded, challenges list, activities list, all those succeeded. It took a while to load the list because I had seeded it with a bunch of data and I don't have any indexes. But they're there. And you get a whole bunch of metrics on what exactly happens here. And you can see how many virtual users were there and what the maximum number of concurrent users there were. So do this, run that in the background when we go over here and talk about other things to make sure that your environment is actually set up to replicate production in a reasonable fashion, since we've been talking a whole lot about making sure the traffic itself replicates a production use case. So first off, if you're trying to test based on existing traffic and potentially changing the application out from under it, you've got logs on what people are actually doing with your system. Use those to inform creation of load test scenarios in terms of what paths users take through the applications and what probability they have of going through each fork of the road. Something like Google Analytics that measures time spent on each page is even better for this than application logs, but sometimes you just have application logs. And you actually do want to run your application performance monitoring like New Relic or Tideways or what have you against your system under test for load testing, if at all possible. Reason being, not only do you get a bunch of useful metrics out of that, but your APM solution will slow your system down, and you want to take that slowdown into account in a non-production environment because your product is actually going to be that much slower if you're running APM there. And a lot of these infrastructure setup tasks are a lot easier if you're running on some cloud provider where you're being billed per hour. And if the build out of that infrastructure is codified into something like CloudFormation or Terraform, versus taking a significant amount of time to get an environment that kind of sort of looks like production, but maybe not quite, and having to set up a whole bunch of physical servers for that, because you can't just tell Amazon, yeah, I know I'm spending 10 grand a month with you, let's divide that by about 500 because you've got reserved instance discounts or whatever, and let's spend 20 bucks on an hour of testing our exact same infrastructure and see what happens. And at the beginning of this presentation, I mentioned that testing from the far end of the internet connection may create different bottlenecks, particularly at, say, a load balancing tier or something like Nginx, and hold those connections open for longer. If that's your bottleneck, then that may change the performance of your system versus testing from one rack over in the same data center. Decide explicitly whether you want the bottlenecks of stringing your test over the internet, or whether you want to test from one rack over and have that variable removed from the situation and realize that you're actually making that decision. And likewise, if you have auto scaling on your system or some sort of load shedding thing where you turn functionality off during load, make sure that that is explicitly either in play or turned off when you are doing your load test in that particular environment. If you're turning those facilities off, then realize that at this point you're running a stress test, and that's probably fine. It just depends on what your goal is on that particular test scenario. So we've got this test going on here, and we're getting a whole bunch of failures to load that challenge list. So my guess is that this is just completely overwhelmed because I didn't index things correctly. So stop that, and notice that it says only 23% of the challenge lists loaded correctly. Activities lists were fine, activities were created fine, but you'll notice that the challenge list response time is kind of ridiculous, and the activity list response time is far behind. We had a fair number of failed checks there, and that sort of thing. So let's actually look at Grafana here. And there is a, there are a couple of K6 dashboards that you can kind of just import, and it'll give you nice looking stats like this. Here's one of them. You can see maybe a little bit more detail and drill down a little more based on the data that K6 is pushing to InfluxDB as it's running the tests. And these actually do happen in real. This data is pushed in real time. You don't have to wait until the test is complete to see what's going on there. So I'm going to now log into there, and then over here, I want to turn off the version of this app that doesn't have the indexes. And turn on the version of the app that does. And start. Start another load test here while we're going through the rest of these slides. That looks like it. All right, so the thing with an application is as you get close consistently to an application's breaking point, you'll have times where the bursty nature of web requests push the application above that breaking point. So you see things like those challenge pages failing or something like that. And as you get closer to that point, the amount of degradation may be nonlinear. Flip side of that is your increase in computation requirement, depending on caching and that sort of thing, may be nonlinear in either direction. Either you get a whole bunch of caching, so tripling the number of users only doubles the amount of load, or you end up, say, filling up a Redis cache, things start getting evicted based on least recently used, and now you're having to go back into the database to calculate things that in a less adversarial load context, you're just pulling from the cache. So keep that in mind when interpreting results on the actual application load as you're running these tests. Likewise, if you have an expensive request and it only happens 0.1% of the time, and you have a cheap request but it happens 1,000 times more, then that cheap request may be responsible for a lot more of your compute and may be the thing you need to optimize. Now, on your web server, in addition to the obvious things of running out of CPU and RAM, you may run out of Apache processes or FPM workers. And while requests can queue up in line for those workers, eventually that queue is going to get exhausted based on your FPM config, and you'll start getting 502s back. You might also run out of network bandwidth, particularly if you're pushing a whole bunch of bits and Amazon decides that their fairness algorithm is going to penalize you for the number of bits that you push, and that is a thing. Those limits are relatively high, but you can't hit them with sustained traffic. And also disk I/O, particularly if you're sharing the I/O for your network with the I/O back to your disk, say in Amazon EPS. And yes, as I mentioned earlier, in the case of Robinhood, they apparently had a DNS issue, and their DNS infrastructure couldn't keep up with load, and then they were down for the single busiest trading day of like ever. On your load balancer, you may have a load balancer that is not warming up as quickly as the requests are coming in. Maybe it's network throughput. Maybe your load balancer can only handle an X number of connections, and you exceed that number of connections. So that might be a bottleneck, and you have to look at your instrumentation there. Or your external services may fall over. Requests to APIs may get rate limited, or they may just slow down or start failing. Likewise, those external services are running over HTTP somehow, and if your network bandwidth is all sapped between your servers and the internet because you're serving web traffic, then there may not be any left over for your external services. On the queuing side, you may end up with a ton of queued jobs, or and not enough workers to handle them, or your queue broker, if you have one of those, may not be able to keep up with the amount of traffic going back and forth, although realistically your workers are going to fall over before, if you're using one of your big queue brokers, are going to be fine. And as CPU usage increases, you may end up with a per job latency hit, which may in turn feed into having way too many jobs sitting there in the queue, and jobs taking way too long to, from the time they go onto the queue to the time that they're actually completed. On the cache side of things, you might end up with a case where a whole bunch of users hit an endpoint at the same time that could be cached but isn't yet. or was cached 5 minutes ago, but has now expired out of the cache, or has been pushed out of the cache due to the cache filling up. In those cases, you now have 50 users hitting that endpoint, 50 different web workers trying to calculate the same thing, 50 different connections to the database, and then they're writing all to the cache 50 different times. That is a thundering herd problem. And with a longer or higher concurrency test, you can kind of suss out those issues that you would normally not see in a normal scenario where somebody is accessing the service one at a time, or at least relatively sequentially. So I have here linked the fixes that I did. There were just a couple of commits to add some indexes and take an n squared plus 1 query down to an n plus 1. And that was enough to give us this. So in this case, we had a concurrency of 10 simultaneous users for a bit, and instead of having a sea of red and a sea of errors, all of our requests actually completed successfully. And we'll notice here that we've got minimum request time of something reasonable. Average is a little over a second, but it's not too bad. And the 95th percentile is only about 5 seconds, so that's not horrible. 100% of our checks actually passed, and we get a bunch of other information here on the amount of data received, which fortunately this is within the same data center. I got lazy, and this is actually the same environment I used for doing this presentation about a week ago in Toronto, in Montreal. So this was a rack-to-rack link in Toronto data center rather than something on the wide internet where I have to pay for bandwidth. But had a little bit of data transferred there, a little bit of data sent, and then it gives us stats on how long requests are blocked and that sort of thing. So that's basically all I've got. Here are some other tools that you can use for load testing. This is a pretty recent list. I went through a couple of weeks ago, and this used to be 2 slides, and I went through and looked at everything that hadn't been touched since like 2017 and removed those. So these are actually under active development. And depending on which language you're comfortable scripting in and which things you want to use add-on-wise, and like whether you want to do clustered load testing or whether you want something super, super quick, you've got a few different examples of stuff you can look up here. So learned kind of definition of terms, what types of tests exist, what types of things that you want to look into for making a test that's actually accurate, both from a client side and actually generating the traffic, and server side of actually getting a production-like environment so that the amount of load that's generated by the load test is representative. And then we actually looked at a demo of how you would build one of those load test scripts on a relatively simple system and then actually run it and interpret those results. With that, there are a few additional resources here that you can look at. A lot of the kind of conceptual stuff I pulled from a Microsoft ebook that is freely available online about load testing. It is linked here. Blaze Meter blog, at least last time I checked it, had a fair amount of information on load testing related topics. Fingers crossed that that blog is still there, because in the interim, Blaze Meter got bought by CA, got bought by Broadcom, so who knows what they're doing there. And I did write an article on load testing in PHP Architect. If you're subscribed to that, then you can get that article there. And Case 6 actually has a test API that you can load test if you want to play around with Case 6, the software package, and they have a couple of samples of scripts to fire load against that test API. With that, thank you very much for your time. This took a whole bunch longer than I expected. But you can find these slides at the URL. I will also post that to Meetup. The code is at GitHub ENSLTX Challenger, including the load test script as well as the Laravel system under test. And you can find me at ENSLTX basically everywhere. Thanks so much for your time, and I'll open up for questions. Yep.
When you have indexes set up, when you run it, in 10 seconds, about how many iterations can you crank through? Yeah, how many did it get through?
Let's see what it says. So I actually set it up for 100 iterations. This one, I did not set it up for being time-based.
Yeah.
Let's see here. Okay, let's try this.
I mean, yeah.
But yeah, keep in mind that I built this system under test explicitly to be kind of slow. So if I were building my own thing, then I would try a bit harder to make it fast. So the numbers that you're going to see here, it's not a limitation of the load testing software itself. It's a limitation of the system under test, and these aren't going to be good numbers.
Okay.
And I've worked on apps that you're doing tens of requests per second on hardware that's now 4 years old. So it's, and yeah, depending on what you're working on, there are plenty of optimizations that you can do to get your request per second up there if you need it. It really depends on workload though. Yeah, there we go. Other questions? All right. Thank you all so much for your attention. And so we ended up here with six iterations. Okay, that was 34 iterations. Keeping in mind though that I had think time in there, so it was not going nearly as fast as the load test system could. But you'll notice that even with that think time, it's still, even with the database optimizations, it was still taking a while to load these endpoints, even with the indexes. So if there had been no think time in those test runs, then those numbers would have been worse. Sure. All right, that's all I got. Thank y'all.
Thanks, everybody. Like I mentioned, our next meetup will be April 2nd. At the moment, I plan on presenting, but if you have a topic that you'd really like to present and would like to jump in on April, please let me know. I will gladly let others speak so that I have a little bit more free time to not have to build out presentations.
I'd be interested in moving to April. I know I had said May, but I actually wouldn't be able to do May because I'm going to be out of country
that's fine.
for the May meetup. So if you want me to do April or June, either one that will.
Really, either one works for me, so.
Laravel Austin. Laravel Austin.
If you want to do,
Okay, I see it.
if you want to do April and you're going to be prepared and ready and everything, then
Presentation wise.
Yeah,
you don't have to tell me tonight.
I'm going to think about it, but I'll let you know this weekend. But I think I probably would be able to be prepared by then. So you actually sit down and do it.
Yeah, take your time, let me know. Like honestly, you don't even need to tell me super quickly, as long as you let me know by like middle of the month.
Sure.
Because that gives me, like, if you're not going to be able to do April, or if you'd like a little bit extra time to flesh things out, then that gives me enough time to put something together for either on airlock or something to that effect. So just let me know.
I mean, I should probably be ready by April. I'm already have pretty good in-depth knowledge of what I'd be talking about anyways, so it's just trying to figure out the toughest lines. Static analysis in PHP and Laravel.
Cool. I love it because I like half-assed through together static analysis in our like Laravel API. So long ago that I'm like on such an old version of Laristan that none of the things that are documented actually work anymore, or just don't work because they didn't exist in that version. So I'm like, fuck, I need to like update this thing and all that. So, oh yeah, like I said, Eric, I don't know if he didn't even look at the RSVP list or something, but 3 medium pizzas for like 10 RSVPs, knowing that we never get 100% is a lot. So please feel free to just take a whole box home if you want to. You can take a Coke or Sprite with you.
I'll take the cheese because that's the only one I can eat at least.
Okay. And if you don't want to, you don't have to. But otherwise, I'm just going to take these back to my office, drop them off there, and let everybody just go nuts. We have catered lunch tomorrow, so I'm sure everybody's going to be like, woohoo, free pizza.
If anyone wants the Sprite, otherwise I'll take it.
All yours.
I had just a question. So I did a lot of Laravel application, and now I'm working on a project I want to deploy it on AWS.
Yeah.
And so I created so I'm ready beginner for deploying things like that. So I created just Docker image and pushed into ECR, yeah, and started with ECS.
Okay.
So it works, but you think it's a good idea?
Yeah.
Can do improvements? Or?
If I had the latitude on a greenfield project and had enough time to like build, to properly understand and build that out, then I would be using ECS right now, and likely I will do that on my next new build project rather than like Kubernetes or whatever. I'm already using Laravel in the Docker container, so that's the logical next step. I just haven't thrown enough time in it, but ECS, particularly since I'm guessing that your application basically performs and works about the same if you run it in local Docker compose, is, yeah, it's quite nice.
Yeah. Yeah, because I've seen the task definition in ECS is like Docker compose. So it's,
Yeah. I went through, actually now that I think about it, this project of mine took, I think almost a year and a half. We basically started it roughly when I started at Modernize, but we are now, our main API that's running Laravel is entirely running off of ECS. All of our EC2 instances have been sunset. We even have separate containers running Horizon for our queue workers, and we're doing basically the Docker compose. So it's spinning up our within the same service, 2 task definitions, one running Horizon and one running the actual web server, each scaling independently. So whenever it's a great. We used to just have 4 beefy servers we were paying for. Now we just have like minimum containers, and then we just watch it spin up to like 14 containers whenever we
Y'all use
traffic. Fargate? Yeah, we're using Fargate config.
so what difference between Fargate and EC2?
Fargate, basically, you don't have to worry about maintaining any servers. They're actually running the Docker containers. It can, I think so, but
The price difference has gone down quite a bit.
Yeah.
Because you pay for CPU.
I mean, yeah, but you do on the ECUs as well.
So, like, I have actually not had a chance to go in and look to see like what the price difference, like compare within the billing tool, like what we were spending on EC2 for running those instances versus what we're spending now for in ECS. But on the flip side, honestly, even if we are spending a little more, the trade-off we've been getting is phenomenal because everything is just running a lot faster and smoother now.
Yeah, and paying a little bit of extra to make sure that you don't have customers complaining about performance. I think it's a good trade-off because it means your support is doing a whole lot less work. So.
And yeah, smaller increments of capacity on Fargate, and that come up quicker versus like, okay, you need ECS or EC2s, and then once the EC2s auto scale in, then you scale in your containers on top of that.
So I don't think it's a bad place to start, honestly. Like,
so what you're saying is that, not the long run, of course, but you're only submitting here's how to do ECS on a production workload to some conference, because you're acceptable.
Yeah, the problem is I ran the project, I didn't do the work implementing it. Like I did initially, but like some of the base level stuff we needed, like we cleaned up other parts of our workflow, like our database migrations, shit like that, that worked up to the point where we finally like built the application into the container and all this stuff. So like I would have to either like chat with our DevOps guy that did a lot of the work and basically just get his knowledge and then steal all that, make a presentation, or basically be like, yo dog, you should speak at a conference, make this into a talk and speak at a conference because you'll get accepted immediately.
Yes.
Or just basically like, hey, you want to help me make this presentation? Then if you don't feel like speaking, then I'll just throw your name all over the slide to credit you and
Yeah.
take it on the tour. So
Because I would 11 times out of 10 watch that talk because I want to do the next thing that I built on ECS with Fargate because I don't particularly feel super enthused about working with EC2s again.
If that talk were available, like it was, as a video, I'd be sharing it to my entire office and be making sure my office watches it at least once a week so that I can get them off of their asses to move towards Dockerizing stuff. But
yeah.
Well, I guess if you can get the presentation, I could probably get mine just indicated on that PHP.
I'll work on it. I gotta finish up this tutorial thing I'm building up for my work thing because I'm basically doing, for those that aren't Ian, I'm basically introducing a conference tutorial type session, but condensed in a workplace setting to do like on-the-job learning opportunities. So of course, implementing this, and I was like, oh, I'll just do the first one so I can get out of the way and give people that are not as familiar with this but want to be like presenters or teachers a example. And I'm like, oh, it's not that kind of time. You probably also happen to stop that recording or saying anything.
but yeah, I've basically put myself in charge of making sure that this legacy application that I'm working on actually has documentation. So I've written about half a dozen pages of documentation already with another dozen pages of documentation to write, and I'm like, oh my god, it's exhausting.
Yes, it is.
But at least then, whenever the next person who gets hired comes to work on this, they'll be able to go, oh, I can read through all of this, get a baseline of what I'm supposed to do, and then I can start getting into it from there. Unlike the person who was just hired right before I started writing this documentation, who was just like, I don't know anything about anything here, and I don't know where to start. And we didn't really have like a training thing set up at all for him, so it was just kind of, here's a project, work on it. It's like, okay, I guess I'm learning by reading the code.
Yep. Modernized is semi in that same boat. It's that plus talking with your teammates and getting information shared with you.
Yeah. So that's pretty much how it is. So it's I'm like, that's not really acceptable, so I'm gonna fix that.
Good.
But especially because like if I leave that company, they're not gonna have anyone who knows how certain things work at all, because no one has spent the time to actually learn learn about what I've done. So,
It's a thing. I've been on the receiving end of that.
Yep.
yeah. So I want to make sure that you're.
See you. Thank you very much.
No problem.
See you next time. Thank you.
Thank you. So I want to make sure that no one is in your boat that you had. So. Yeah. Anyways. Y'all have a good day. Good night, as it is.
Same thing.
And
Who keeps track of what?
I know, right? I'll ping you probably sometime this weekend.
Yeah.
Depending on how we'll put together. I have my thoughts.
Apparently Daniel's here eventually.
And Daniel was watching. Kevin was watching
Oh,
the live
nice.
stream.
Hi Kevin, hi Daniel, if you're still there. If you're not, then I'm talking to no one. Bye.
Daniel was like, I feel like I'm spying on y'all.
That's amazing. Yeah, I dropped it in my Slack for work. I don't know if anybody watched it, but the same link works for once the stream ends, it'll be the same one for the recording.
Yeah.
So, okay.
Yeah. I mean, even if people weren't watching now, they might be able to watch tomorrow.
Exactly.
Yeah.
See you.
All right, y'all have a nice night.
Have a good one.
Bye.
Yeah, I finally just broke it down. Like it winds up being, since I'm working with an hour and a half time block, I wound up going with like roughly going to spend the first half hour just kind of going over like, since I'm especially.
An hour and a half time block, also known as somehow this took that long.
Yeah.
I don't understand that. I did it in 45 minutes last week. I cut out pieces, but I did it in 45 minutes last week, and yeah, okay, fine.
Yeah, it happens. Yeah, like basically the first half hour is going to be like, because I'm also going to, like a lot of our backend devs are probably at this point going to know like what the fuck I'm talking about, so they either show up, either A, they've been faking it the entire time, I doubt it, just recording, or they're just getting a refresher, but I'm more gearing it towards our front-end developers in case, or QA engineers in case they want to like basically learn like, hey, what the hell do all those full stack devs do? One of the